Good morning, everybody. My name is Karl Wietsch. I'm the Secretary General of Terena, and it's my pleasure to be sharing this session this morning. This is a rather special session in the conference. It's a session with industrial presentations. Terena is best known as an association of national research networks, but we also have associate members, including a number of companies. And we're very happy that we have those companies as our associate members, not because of the membership fees that they pay, because that's a relatively small amount, and in that respect we'd rather have them sponsor the conference, which actually brings us more money, but because it's a sign of their continued involvement with the research and education networking community, and that's why we like to have them on board. We used to do nothing special for our industrial members, but last year we decided to start an experiment by giving them some speaking time at the Terena conference. And while the general rule is that at a Terena conferences you're not supposed to do any commercial talk, but just have an objective way of presentations, this session and the next session is an exception, and companies are actually welcome to tell that their products are much better than the products of the other speakers in the same session. So I hope that that will give us a lively session, maybe even some debate, because the speakers are each other's friends, but also each other's competitors. It's important that we divide the speaking time equally. We have 4 speakers, so there is about 20 minutes for each of them. And without that, further ado, I'll give the floor to our first speaker, who is Antonio Conde of Cisco. No. There you are. Okay.
Okay, can you hear me? Okay. Thanks a lot for the introduction. I'll try to be short because we are a little bit late and my colleagues are waiting with their guns. Virtually into reality, this is the main slogan for this conference in 2009. And we're talking today about one of the key elements in making this possible. I mean, making the virtuality work together between different teams. And that's why my speech today is called Collaboration and Dispersed Teams. And I want to start with a short, very short video on when Cisco talk about collaboration, what are we referring to?
Scraps. Mom, something's wrong with Scraps.
Did you try rebooting him?
What if he's really crashed?
Don't worry, we'll get him fixed. Find Dogbot tech support. Telepresence.
I want to get this resolved for you as quickly as possible, Miss Fuller. If it's okay with you, I'd like your permission to access Scraps and download his history.
Sure, that's fine.
I'd like to share this history with a few of my associates. If you'd like, you can go back to what you were doing, and I'll contact you as soon as I have more information.
That's great.
Perfect.
Ja.
Have you ever seen one fail to revert back to zero position?
Es hat gerade heute Morgen angefangen.
Yeah, I see what you mean. I'm getting trouble tickets from Europe and Asia.
müssen es sofort auf Stufe 3
We need to
ausweiten.
escalate this to Tier 3 right now.
Ich will es sowohl den Hardware- als auch den Softwarekontakten
I want to share this with both hardware and software leads.
Right away. Meanwhile, take a look at the customer info. I'm sharing it in the workspace.
Hello?
So basierend auf, was wir mit der Beta-Version haben.
So based on the issues we initially had in this beta version, is this anomaly caused by hardware or software?
Well, it could be the hardware issue we were seeing earlier. Jaw assembly. I'll share the schematic.
Possible. I'll open the call stack and share it.
Great. Guys, I'm going to check in with the customer and give her an update.
There was some issue with the jaw assembly popping up.
Ich dachte, wir hatten diese schon
I
gelöst.
thought we got those resolved.
Or spin the resistance sensors. They can seize if they get overloaded. And based on customer information, they were getting stressed beyond spec. Bob's team was working on a fix.
That stress, combined with the heap corruption and the jaw subroutine, caused the failure. Fix was done early this morning and has just been released from virtual testing. Says here, it's good for customer release, pending product manager approval.
Let's take a look.
I'm a go here.
Gut.
Looks good to me.
We have several of our best people sharing Scraps data files, so they should get Scraps back up and running. In fact, would you hold on one moment? Oh yeah, there it is. May I have your permission to install the new software?
Yes, that's fine.
All right. Well, Scraps should be up and running in in no time. I'd like to offer you a free functionality upgrade that, as a parent, you might find interesting.
Plus y plus x. Come on, boy, let's go outside.
Sure, but not until you finish your homework.
Don't show this video to your kids, especially in Christmas time. Everything we have seen here, except what we call live translation, everything is technology available today. Live translation, we are working on that to be able to translate on the fly between people with different languages in a collaboration session. What we have seen here is a very machine working pals that work together to deliver the results that the customer expects from them in a timely and productive way. But it's not easy to make a team work as a one single piece because of the geographical dispersion. If we look at a book by Pern Candola called The Psychology of Effective Business Communication in Geographically Dispersed Teams, he says that it takes 2 weeks to build trust in an electronic relationship. Also, he says that it takes 4 times longer to communicate electronically a message than face-to-face. And also that it takes 17 weeks to have multicultural teams working together. So it's not easy, but we better get used to it because in the next decade, productivity, the collaboration will drive between 30 and 50% of our productivity. If we look in the past and how we got to this situation, we come from the very early days where we have had collaboration, forever. I mean, collaboration exists from the very beginning of the times. At the beginning, in a centralized model, collaboration was performed by a method we call working around, because everything was centralized in the main office, and the way we used to collaborate was having a walk through the, to the machine or to the copy machine, etc., and starting to chat with the different colleagues, okay? Then when we moved to a more centralized model between the 60s and the 70s, where started to appear the headquarters and the branch offices, collaboration started to suffer a little bit of a productivity gap because we had to use the phone and the email to collaborate, to establish a relationship with the rest of our colleagues. So there was the collaboration and the productivity started to drop a little bit in those environments. And then today, where we are absolutely global and variable, we can work from the airport or the train or the different offices around the world or around the country, etc. The productivity is even suffering more because there is a lot of distance and a lot of different methods to access the information that it makes quite complex to get results in a timely manner. So in all those circumstances, we at Cisco only see one common layer, and is the network. We think that the network is the platform for unified communications and collaboration. Because from the beginning, first, it started to provide connectivity services to all of us by connecting our computers, our laptops, our systems, and started to share some documents. Then, the introduction of unified communications, we started to use the network to converge all forms of communications into one single platform and to be able to use telephony, video, etc. over the network. And finally, collaboration is allowing us to share all different medias between the different participants of a working team and share transparently our information, no matter where we are, no matter what device we are using. We have seen in the video, it's not a question of a desktop machine, it's not a question of a fixed phone, it's any device we use in our day-to-day job can be included in this portfolio of solution. We at Cisco decided to create a portfolio of collaboration applications to put it on the market, and we started looking at two different approaches. First one is what we call the consumer world, where everything happens very quickly. It is people that is connected to Facebook and Flickr, this kind of applications on real time. Everything happens at internet speed, which is very quickly, very fast. And they need to quickly adapt to the technology because the technology is always providing new applications. There's a lot of developers in this cloud putting together applications and services and giving them to the market in a very quick manner. And on the other hand, we have the IT guys in the enterprises or in the institutions that wants to have the security, reliability, stability, availability, etc. In one word, the consistency of an enterprise-grade network to provide the application to the enterprise or to the corporation. Traditionally, in this scenario, it takes much more time to put services up and running because we must make sure that they comply with enterprise policy and the criteria for stability, security, etc. before we put it together. So we have two different approaches to create a single communications portfolio. We have, on one hand, the application part and the employee and the enterprise models, and on the other hand, the delivery model. So we need to have the ability to put applications and services very quickly, but with the flexibility and security to be deployed on an enterprise model. So what we decided is to put together the best of both worlds by creating these applications that are customizable for the different customers or for the different institutions, and that on one hand allows you to have a secure and reliable platform on your LAN or on your corporate network if you wish to, where you only have to rent those applications and services from a service provider. Unfortunately, it's not easy to put everything together. And collaboration is not just. If you have to give the step and go into the collaboration, world, you have to focus on 3 different areas. First one is, of course, technology, because it must have technology. It must have been make available to the market some technology to put all these services together. But also you have to look at your own processes, internal processes, to adapt your processes to that technology. So it doesn't, I mean, it makes no sense to have the latest technology if you continue to have your business processes in the old-fashioned manner where the signature must come from the general director, and the general director is only reached by email or by fax, and the guy has to sign. Okay? You have the technology, but your processes are not adapted to collaboration model. So that's the second step. And finally, it's a question of culture. You have to encourage your colleagues and the rest of your workforce to embrace collaboration and to use that collaboration to improve themselves not only in the performance, but also in the delivery of the solutions to your different customers, etc. So what we have put together is a set of solutions based on our network infrastructure, and that set of solutions will take care of most of the important information you need for deploying collaboration in your different environments. Solutions like applications like not only if the user is available or not, how he prefers to be contacted by email, by phone, by leaving a message in the mailbox, in the voicemail, etc. Also, the preference you have in the devices that you use. If you prefer to use your laptop, if you prefer to use your smartphone, if you prefer to use the fixed phone, etc. I mean, all those information, all that kind of information, along with credentials, I mean, what are you allowed to do in the network, is put together in the different solutions that we put in the market, like, for instance, telephony, contact center, web audio and video conferencing, and unified messaging. When we talk about collaborative solutions, we are not talking about just a single service, but the full functionalities the network requires to make this application successful. For instance, it makes no sense to have IP telephony on your LAN if your LAN doesn't have enough capacity to handle that traffic. It makes no sense to buy collaboration solutions for document sharing if your WAN does not allow for that kind of traffic. So you have 2 options. If you already have Cisco gear in the bottom, the network will automatically take care of that requirement and will configure the bandwidth and the control admission, the quality of services, etc. in the network to make this happen. Okay? Does it mean that this only works when the network infrastructure is Cisco? No. It's just it's an advantage because you have automatic recognition of the different traffic models, and the network and the equipment can adapt to that different traffic models. Also, you have video as a native application in your network by means of desktop video using the clients for the PCs, or either with telepresence, which is our largest video solution with what we call face-to-face meeting using video technology, and of course the traditional video conferencing also available on this infrastructure. I think the best thing of all is that all these components and all the components that you have seen before are absolutely interoperable. Okay? Finally, Web 2.0 applications that provide the speed and the ease of use of this kind of delivery model that we have talked before. And what it doesn't exist, it can be done because we have an application platform that is able to, visually generate applications for the environment. And last but not least, all these applications that we have seen relies on a very well constructed and solid architecture that we call our collaboration architecture, that goes from the very bottom of the network, the Cisco gear on the bottom of the network, from different delivery models, from on-premise to on-demand services. You can have on-demand services for some of the applications, or you can have on-premises services in your infrastructure. Based on network services running in the network infrastructure that are accessible through APIs. So these services can be queried from any application that you develop, and you can develop those applications either using standard languages like XML, AXP, etc., or either you can use the Cisco Unified Application Environment, which is a platform for visually generate these applications. And all of them interact with any workspace device that you want to have, including, for instance, just to put a real-world example, using my iPhone, I can log into a meeting place or WebEx session where I can share slides and documents from my mobile device at any point in the airport or whatever. Okay? So thank you very much, and this is all I had ready for this morning. I'm open to any questions you may have.
Thank you very much. You stayed nicely in time. Actually, you have 1 minute left, so if there is one question from the floor, we can take that. If not, then let's thank again our speaker. I like dogs, and I'm not always at home, so I love the option where you can switch it off when you go to a conference to Malaga. So when Cisco really offers this product, I may be one of your first customers. Thank you.
All right.
So our next, let me get you started while I introduce you, Rob.
Okay.
Our next speaker is Rob Adams from Equinox. Equinox may be a company that is not so well known to you as Cisco, but he will introduce the company himself. Equinox is a new member of Terena. Actually, we think that they will officially become a member tomorrow, so we're very happy to welcome Equinox here at our conference, and we are really looking forward to hear from you a little bit more about what your company is doing. Thank you.
All right. Can everybody hear me? Yeah, sounds good. All right. Since we are new, first I wanted to say I appreciate everybody taking your time off from some of the other sessions to come in and let us talk a little bit about what we do. It really does mean a lot to us. Because we are new, I wanted to spend just a few minutes telling you who we are, since many of you probably don't recognize us. We are just slightly bigger than Cisco, maybe double the size or so, but that's yeah. We're actually a private company. We're based in France. We're actually a European company. We do business all over the world. So we have many accounts. I'll show you a quick list of accounts. Throughout Europe, the business we do is with universities, R&E, or research and education. We deal with carriers. We deal with cable companies. So we run the breadth of the various different types of telecommunications companies there are out there, or companies that need telecommunications equipment. What do we do? Basically, our focus is layer 1 transport. So we are an optical transport company. In fact, if you look at our equipment, we specialize in DWDM, CWDM. You'll see that we do have a hint of next generation ADM type functionality. So there's some very unique features that we offer that other transport gear doesn't offer, that allows us essentially to replace ADMs as well as older transport equipment in your network. So not only layer 1, we kind of bleed a little bit into the ADM business as well, and I'll talk about that in a few minutes. We build what I call dynamic optical transport systems, and what I mean by that is we have a very programmable technology. So our whole technology is based on a device that we created, a chip, that we call transport on a chip, and what we've done is we've consolidated all the electronics in a transport system into a single chip. And that chip is programmable in the field, so what it allows us to do is address new requirements in the field very quickly. So when we get requests for new cost-optimized applications that are very specific to what you're doing, we can generally meet them very quickly. If you're wondering about, in the CWDM, DWDM space, what types of networks do we address, we are one of the few vendors in the industry that has a single system that addresses all of your CWDM and DWDM needs. And I literally mean that. If you're going very short distances with CWDM, we do that. We have systems that go very, very long distances with 80 wavelengths plus as well. We do 40 gig ROADMs, all the newer generation technology that you see in most of the transport systems. And I'll talk about that a little bit. Technical expertise, we hold patents in aggregation. We have some very efficient aggregation techniques for aggregating Ethernet and other technologies that you might be interested in. We also are one of the few in the industry that offer high definition video. I don't know if any of you do any distance learning where you have a need for uncompressed high definition video, but we handle that as well. And one of the unique capabilities we have is that we can multiplex any mix of services over any type of service. So, like I mentioned before, not only do we do transport, so for instance, we have a capability of multiplexing HD video and Ethernet and carrying it over either a wavelength, or if you have a 10 gig E service and you want to carry it over 10 gig E service instead of a wavelength, we can carry it over that 10 gig E service as well. So we're not just WDM, all right? The T-chip technology, very quickly, what I mean is if you take a line card out of a transport system, typically you'll see lots of chips, and the number of chips that you see will be dependent on the vendor. The types of things you'll see are technology framers for each of the ports. You'll see multiplexer chips. You'll see backplane framing chips. If you look at our boards, it's a single chip. And what that does for you is it basically, number one, as I mentioned, it's fully programmable. We can update it in the field. So if any of those ports, there's a new technology you need to support, we can add it on the fly. Also, ease of manufacturing, and what that means to you is we can basically get things to you quickly because basically the boards are very easy to construct. Very low power consumption for ongoing use because we've eliminated a lot of electronics on the board. Very small space. You'll see our systems are very compressed, and that's because we've eliminated all the electronics on the board as well. In terms of customers, like I mentioned before, we run the entire gambit. We've done business, a lot of our business is actually done through partners. So we've done business with universities, research systems in Europe and the United States. You may not have heard of us in those particular domains if you work closely with some of these universities or companies. And the reason for that is we're probably selling for a partner in those particular accounts. All right? So now going to the topic of the presentation that I had up front, that's enough about us. Reducing the cost of optical networking. What I wanted to do is just take a few minutes, and I'm touching on quite a few technologies, so I'll run through them quite quickly, and just talk about some of the technologies that when optical vendors don't typically talk about a lot that save you money today, right? Everybody talks about ROADM, 40 gig. I'll talk about those a little bit, and we all know they're out there. We all know we have them, but there are numerous other technologies out there that nobody talks about that will save you a lot of money if you're trying to deploy an optical network. To give you examples, areas where you want to save money when you deploy an optical network, number one, reducing your infrastructure, right? So, you got to admit, optical infrastructure, the fiber itself, generally costs more than the equipment, right? So basically, saving on the equipment is only half the job. Really, where we can get you the biggest savings is if we can efficiently use your optical infrastructure or allow you to eliminate some of that optical infrastructure. So I'll talk about technologies like single fiber, right? Most transmission systems are on 2 fibers. We can transmit on 1. Minimizing the number of wavelengths through efficient muxing schemes, those types of things, right? Reducing capital costs. Number one, the one thing I'll mention in the presentation, I'll talk about ROADM and those types of things, but make sure when you're selecting your transport system, you're not selecting something that's overkill. So a lot of people love ROADMs, for instance, because it's really cool. For those of you who don't know what a ROADM is, it's relational optical add-drop mux, which allows you to dynamically drop wavelengths at cities. If you're going point to point with an optical channel, and then you want to drop off services from city to city, a ROADM allows you to do that and do it dynamically through programming. Very nice technology. There is a need for it in the market, but not everybody needs it. And what people don't understand is there are very flexible optical add-drop mux technologies that are much cheaper that will satisfy the requirements of many, many people. So when you're shopping, you need to make sure you look at both. A lot of people dismiss the optical add drop architectures because in the past they were limited to bands or limited to 8 channels at a certain site, and they didn't like those limitations. But what people don't know is a lot of those limitations have disappeared. Look for platforms that allow you to scale. If you look at transport platforms, when they talk about scalability, many of them are just talking about adding transponders. There's so many other ways that optical transport systems can scale. And that's an important factor. So for instance, on our system, we even have, if you don't need amplifiers, you're fine, but if you do need amplifiers, we even have a scalable amplifier architecture where we've got a lower cost amplifier technology that allow you to take just a few wavelengths, push it whatever distance you need to push it, and then you can upgrade that amplifier technology in service if you ever go over that number of wavelengths. Reducing ongoing costs, power, certainly an important factor. Eliminating mid-span sites. Typical transport systems, you have your 2 end sites between which you're transporting services, and then you've got amplifier sites or some sites in the middle. If you can eliminate those sites, you can save yourself a lot of money. So in terms of single fiber technology, a lot of people dismissed this technology years ago because most people could only do roughly 8 wavelengths on a single fiber bidirectionally, which means 8 10 gig services or something like that. And most people didn't want to be constrained to that. That was enough for a lot of people that they didn't want to be constrained to that. What you need to know is that with the systems out there today, like for instance in our system, we can do 72 10 gig services bidirectional on single fiber, probably more than you'll ever need. So if you have the option of not buying a transmit and receive fiber and only buying a single fiber, leasing a single fiber, definitely need to look at this technology. It'll save you a bundle of money on infrastructure. Ethernet, transporting Ethernet. Like I said in the beginning, we have some ADM type capabilities in our system. So we've got what we call a layer 1 Ethernet ADM. Most transport systems, if you look at transporting Ethernet, what they do is if you have remote sites and you're going to a single site, basically you have to have a wavelength from each remote site to the single site. What we do is we allow you to run a single wavelength and basically just add and drop ADM or giggies around that wave. So we eat a lot less of your bandwidth in your fiber, so you can use that bandwidth for other things, right? FEC technology, for those of you who aren't familiar with FEC, it's just a software way of making things go further, right? And this technology will benefit you instead of using amplifiers. So this technology will benefit you whether or not you're using amplifiers. So for instance, if you're going short distances, you don't want to use amplifiers. Most systems are 80 kilometer range, depending on the number of channels. If you're talking about full channel counts, there may be 80 kilometers, somewhere around there. FEC technologies have gotten better in the past few years. We're not the only ones working on the technology in the past. They've given you 6 to 8 dB gain. For those of you who are familiar with gain technology, the technology out there now that companies like ourselves are starting to introduce is like 10 dB gain. And to give you a feel for what that means is 3 dB of gain is basically double your channels or double your distance over an amplified span. For an unamplified span, that'll add 15, 20 kilometers, but that's 15, 20 more kilometers you're going to get without having to add amplifiers. Saves you a lot of money. So an important thing to look at is what type of FEC technology is the vendor utilizing. If you do happen to need amplifiers, then FEC technology will also help you minimize the number of amplifiers. So you say you go over that 110 kilometers, you need amplifiers. For instance, with our technology, if you do end up needing the amplifiers, you go over that 110, we can push you over 300 kilometers without the need for any inline amplifiers, just putting amplifiers on the end of the span, which ends up saving you quite a bit of money as well. Another technology that I want to talk about very quickly. A lot of you already have DWDM systems in the ground, right? You have transport systems, and you're worried about, or you may feel constrained to that particular system because you think upgrading that particular system, you can only upgrade with the transponders from that particular company. That's not true at all. In fact, WDM technology moves very quickly, and it comes down in price very, very fast. So you should always be looking at your options out in the industry, not only ourselves, but everybody. Because even the systems, most every WDM vendor, if you already have a WDM system in the ground, can run their transponders over that system in the ground. So basically, you can upgrade it using somebody else's technology. So if your particular vendor doesn't offer a transponder or a type of service that you're looking for, or if your particular vendor is not kept up with cost reduction in the market, then you can go to another vendor and you don't have to overlay that system. You can run their transponders with the existing system in the ground. So just really quickly pulling all these technologies together that I just talked about. So say you've got a ring, a campus ring, and you're running an Ethernet service from site 1 to site 2, you're running one from site 2 to site 4, you're running another one from site 1 to site 4, you're running one from site 3 to site 4, right? So each colored line represents a wavelength and an Ethernet service. And the way most systems work is they require 2 fibers. Depending on your distances, they require amplifiers. If you look at the technologies I just introduced, we get rid of all those wavelengths. So you remember all these other guys required a bunch of other wavelengths to carry that. We can do that all in one with the ADM technology. We can eliminate one of those fibers. We can eliminate amplifier sites. So you can see how dramatically all those capabilities can bring down your cost by reducing your infrastructure and reducing your hardware costs as well. Another capability I wanted to mention quickly, there is a LAN-PHY to WAN-PHY converter. I know this is an older technology, but many of you may run into cases where you're trying to interconnect your campuses and you're trying to connect into a carrier's network and all he has available is SDH. And the problem for you is basically if you have a router, you've got to buy one of those SDH blades, which are ungodly expensive. And what we have is actually a product that converts LAN-PHY to WAN-PHY. And it's very inexpensive. It's probably a fourth to a fifth what you would pay for that expensive router blade. And you just plug it into your router blade, and it does the conversion to WAN-PHY for you, or to SDH for you, and you can ride right over that carrier's service. So some people still run into this, and we actually sell lots of these. In fact, Global Crossing, who's also one of the sponsors, sells that product quite abundantly. So if you run into that case, just so you know it's out there and it's something you can look at. I mentioned before that I would talk about ROADM technology. For those of you who aren't familiar with ROADMs, this is an example of what a ROADM will do. So I've got 8 sites here basically running through a single site, the site in the center. And what a ROADM does is it's a programmable technology that lets you reroute. So if you've got services coming in from one site and you want to route it to another site, it lets you, via software, reroute those services to any of those sites you want. So I can take a service coming from here, and today it goes there. Tomorrow I want to route it over there. This is an example of what you would call an 8-degree node, the node in the middle, because it's taking services from 8 different nodes, and it's basically routing them to 8 different nodes, right? This is a very scary thing, right? Most of you will never see this in your lifetime. In fact, if you do see it, run as fast as you can, because it's trouble. It's a lot of degrees, right? And most of you will never see it and have to deal with it. The problem is that ROADM technology, a lot of you have probably priced ROADM technology, is geared toward this configuration because this was viewed as the maximum size configuration you would have. Now, what's happened in the market is 90% of the people have never gotten to this, right? So that you'll see 1 or 2 configurations that look like this. And if you look at existing ROADM technology in the field, it's designed such that you can accommodate. What I did was I just took that node in the middle and I blew it up, and this is what's inside that node. And basically what you have are these WSSs, which are wavelength selective switches. They're optical switches that take the wavelengths in from each degree and they switch them to another degree. And that's what allows it to be dynamic. The problem is the initial technologies for doing this were designed for 8 degrees. So then say, for instance, you want to do 4 degrees. That means you still put one of these 8-degree nodes on each degree, which means you're paying for 8 degrees, but you don't really need 8 degrees. And that's why a lot of the initial ROADM technologies were very, very expensive. In fact, it gets even worse if you want to go to 2. You're still dropping in 2 of those little 8-degree ROADMs, but you don't really need 8-degree ROADMs. What you need is a 2-degree ROADM. Well, luck has it that there are newer technologies out there, or there are technologies out there that are designed for fewer numbers of degrees. There are technologies out there that are designed for, say, 2 degrees. And those technologies are a third to a quarter less expensive than the 8-degree technologies. So if you are interested in ROADM technology, and it's something you have to have for whatever your network requirement is, it's a beautiful technology. And what you can do is you can take those nodes that are designed for lower degrees, and many vendors have this. It's not only us, but this is one thing that we've pioneered in the industry, I think. And basically what you can do is you can just kind of chain them together. So if you do need more degrees, you can actually chain these together to get more degrees. And what ends up happening is they end up being much, much less expensive. So if you take a network, and most of your ROADMs in your network are actually 2 to 4 degrees, then this technology ends up being much cheaper. The green line represents what putting 8-degree ROADMs everywhere would cost you, and the blue line represents what putting, say, 2-degree ROTAMs everywhere would cost you. It basically ends up being much, much cheaper. In fact, for the 8-degree ROTAM technology to be cost effective, effectively you have to have 90% of your ROTAM nodes greater than 4 degrees, which most of you will never have, right? So there are technologies, if you've looked at ROTAM, you brushed it off, there are technologies out there that are much, much less expensive, so you may want to take a look at it again. And really quickly, the last thing I wanted to mention before we go to questions is our 40 gig technology. So there are a number of 40 gig technologies out there. Many of you probably wanted it, needed it, but looked at it and it was just ungodly expensive. The reason for that is that they're based off of 40 gig technologies. 40 gig technologies sell in very low volume, so they're basically very, very expensive. So very nice technologies. The other problem with 40 gig technologies today is they don't go very long distances, right? So they don't overlay, they have PMD issues, they have all sorts of dispersion issues. So they don't overlay your existing network. What we did was we said, those are great technologies. One day we will create a technology just like that because it's beautiful. But in the meanwhile, what we'll do is we'll take 10 gig waves and we'll tightly bond them together into the same spectrum that a single 40 gig wave sits. So for instance, most of you have 100 gigahertz systems today. And our wave bonded 410 gigs is in 100 gigahertz. So you get 40 gig worth of bandwidth in 100 gigahertz, just like a native 100 gig. And we call this wave bonding. Gives you a 40 gig interface, true 40 gig transport. But the beauty of it is, it truly is today less than 4 times the cost of 10 gig. Because the underlying technology is 10 gig. And by the way, as 10 gig it gets cheaper too. Most vendors who are selling you 40 gig will say, oh, it'll be as cheap as 10 gig in 4 years, right, or 2 years, or whatever it is. But what they don't realize is that the cost of 10 gig is going down, so that target continues to go down. With this technology, we'll continue to ride that wave. Has the same PMD and dispersion performance as 10 gig, so it will overlay existing 10 gig systems. In fact, the first iteration of this, we have 4 10 gigs into a 40 gig. You can upgrade your existing system. This is a fully tunable on the line side. It will run over anybody's system. You can basically take our 40 gig transponder and run it right over your existing system in the ground without even putting in our optics and our line system. So it's a beautiful technology. It gives you a very low cost 10 gig drop technology. Because we're not doing modulation into 40 gig, we're actually carrying individual 10 gig waves. If you need to drop out 10 gig at campuses or intermediate points, very inexpensive to do it with this technology because we don't have to do a demodulation. All right? And unlike other 40 gig technologies, you can run this adjacent to 10 gig. You can even interleave 10 gig and 40 gig services. And finally, basically, a 40 gig solution that's affordable and market ready. So in summary, if you lower your cost of infrastructure, lower the cost of equipment, gives you lower ongoing costs, gives you lower cost of ownership. All right? Any questions really quick? I think. Yep. Well, if there are no questions, we're at the booth. So if you want to come talk to us, we'd appreciate it. Appreciate your time. Thanks.
So that takes us to our next speaker, Mr. Thomas Schneider of ADVA Optical Networking. The floor is yours.
So, can you hear me? Okay, thank you, Carl, for the introduction, and thanks for the opportunity to speak to you on a quite free subject. So we decided to give you some introduction, actually, on ADVA. Okay, so here we go. So actually, this is the 5th Tirreno conference that ADVA is sponsoring, and where we also have a booth at the exhibition area. It was a very good experience for us in the past years, and 2 years ago we also decided to get a member of Tirreno, an associate member, but also quite welcome, as Carol explained in the beginning. And for us, it's a good experience also to exchange experiences with our existing and potential new customers. So on our company, ADVA was founded in 1994, so we can look back on a 15-year history in optical transport. We started to do WDM very early, after let's say 2 years 1996, we had the first WDM product on the market. We come from the enterprise space, which was originally the need to connect big data centers, backup data centers for banks, and that's where it all started. The revenue 2008 was close to 220 million euro, and we have approximately 1,000 employees worldwide. We are a German company, maybe that's not so obvious, but our headquarters is in Munich, in Germany, and our main production facility is also in Germany. You see a picture here of this company. We have around 250 people here, research and development for hardware plus production and some administration. And we have some other sites for engineering in Europe and a few also in the US. What do we see as the main growth drivers for optical networking? So this is video, definitely. This is what we see as the number one driver here. Also coming from the various end customers. Look at YouTube, for example. This is really boosting the bandwidth demands. So this is a driver for our carrier customers to increase the bandwidth on their core networks. And also for enterprises, this is a driver to install video conferencing systems, to save travel costs, to have lower airplane travels like we heard in the morning. This would be a very good way to do this actually. So video is really driving bandwidth is going up. Second thing here is Ethernet. Everything is migrating to Ethernet. SDH is still existing somewhere, but everybody's really migrating in the carrier space definitely, but also in the enterprises, and also all entrants are going to Ethernet services. The third thing is storage. I told before we come from the data center enterprise environment, so storage is also boosting bandwidth demands for networks. The data from CERN, for example, this is distributed, as most of you know, all over the world to the various research centers, and they are not able to store all the data locally, so this is also a reason they have to distribute it. So this is a huge distributed storage network, actually. To give you a brief outlook on our product portfolio, we are doing optical plus Ethernet transport. That's where we are focused at, and pretty successful over the past years. Starting here at the bottom in the customer premise, you see here various access technologies. So here you have fixed line, copper, coax, or fiber getting connected to a WDM access ring. You could have your wireless base stations getting also connected via different kind of equipment to a access ring. Here on the right side, we have a storage connectivity link between two data centers. And here we have a Ethernet access aggregation. So the FSP3000 you see here and also here, and the core ring and up to the backbone, this is our main WDM transport platform. And the 150 you see on the other boxes here, this is for Ethernet access and Ethernet transport. We have a network management system to manage the complete portfolio end to end. We have GMPLS control plane for the optical transport available. So that's the broad overview on our portfolio. And actually we go here from these access equipments here to the access rings, meter core rings, and down to the backbone, where you could really connect national backbone nodes all over the country or between various countries. This is from a distance point of view, so the system is really extremely scalable. We have a broad customer base in the carrier and in the enterprise market. Here's a small selection of our carrier customers and enterprise customers. You can have a look at this also. There are some entrants also, and I have a slide at the end of the presentation to show you the entrants we are already cooperating with. Requirements from entrants, what we see here as an optical networking vendor. The reach in the backbone networks has to be between 1,000 and 2,000 kilometers, unregenerated distance, so no optical, electrical optical conversion. This is a key requirement to drive down costs. The wavelengths so a 40 times 10 gig network should be sufficient for the next 5 years, which is the average time a optical transport network is used. So I would say between 5 and 8 years, and then there is a major upgrade to new technology. 40 gig is something which is considered today and deployed by some airlines, but most of them are relying with 10 gig and considering a major upgrade. And first products will be on the market. We have a lab demonstrator already out since a few weeks, and we are planning first field trials early 2010, 400 gig transport. And InfiniBand is also a topic. We had a presentation on Tuesday, no, it was actually Monday in one of the sessions on InfiniBand transport. So you could also do InfiniBand over distance. Could be an interesting topic. I said we have a control plane, so this is available here, GMPLS control plane for optical networking transport. We have ROADMs, 2 degree and 8 degree ROADMs, very scalable. I have a few more slides on this, so this is the second part of the presentation to give you some details on our ROADM technology and ROADM architectures. So let's go to the next slide here. This is a generic copper backbone, could be an NRAN backbone also. So what you see here is the core backbone, including some major sites here with ROADM technology. And there's a mesh interconnect. And these here are degree 3 ROADMs, so 3 outgoing incoming directions. There's a core router, there could be a second one connected at a central location. There we have a second ring, could be a smaller area, regional network, collecting services from various sites, equipped here with degree 2 ROADMs, also WSS based. And here on the bottom we have various Ethernet access or lambda collecting technology. And this here on the left side, this could be also an Ethernet local loop connection, or if it's still existing, some SDH, maybe E1s could be collected here for the telephony central stations, so this is also an option. And this can all be actually then aggregated to this first ring and then back to the backbone ring. Some requirements, some features that what you could do here with this kind of technology, maximum equipped. So this is the SP3000, as I mentioned, the WDM platform that we have here. You could do packet optical transport, also to mix optical and Ethernet transport in the core and access rings. You can use 8-to-1 and 2-to-1 WSS based ROADMs. So depending on your network layout, this technology is very scalable. Actually, you can start also with 2 degree ROADM and can upgrade it later to up to 8 degrees. So with every degree, there's an additional module added. So even if it's an 8 degree, it's very scalable. If you do a full 40 lambda network, you end up here with 400 gigabit per second capacity. If you're at 10 gigabit per second, or at 1600 gigabit per second if you are at 40 gig per second. So this, for most customers, this is today sufficient. So you can also learn lambda services from any to any core node with up to 40 lambdas without regeneration if you have an all optical WSS-based ROADM network. And you have a control plane here for end-to-end service provisioning. just a sample picture here of a ROADM technology inside view. So this is a MEMS array actually, having the various colors coming in here, being distributed to one of the 2 or 8 directions, and then here's the outgoing path. Similar to, you know, from DLP projectors, this is also MEMS technology. Here the difference between a standard passive OEDM node, what is known since many years, and a ROADM node. So on the OEDM node you have fixed colors on the drop and add ports, and you have no flexibility here to change actually the port or the color. So everything is fixed. This is a 3-port filter. So 2 are aggregated here, so you can add and drop 2 colors which are predefined. While with the ROADM node, actually, you see here at the bottom, this is a WSS-based ROADM. You can add and drop any combination of colors, but the ports actually are fixed to one color. So, for example, at a 40 lambda node, you have 40 ports, 1 for each color, and you can switch them one between each other. The next evaluation would be a colorless and directionless ROADM, where in addition to the ability to switch the lambdas, you can also have flexible local add-drop ports. So you could switch here any color in any port in any direction. So this gives you the maximum flexibility. And there are many advantages of this technology. Actually, you can really start to do restoration here. So instead of having everything redundant in your network to do a full protection, you could use predefined paths for restoration of your services in case of a fiber break. And you can build up dynamically light paths. This is more inside view on a colorless and directionless node. So this is a generic network here. And this is one of the end nodes. Here with 3 directions, so this is a degree 3 node. Here we have 1, 2, and the 3rd degree, and this would be the local side here. Again with WSS technology. Tunable lasers, of course, are also needed on the channel cards. Otherwise, this does not work. So you have to be able to tune your channel card to each of the 40 wavelengths, and in addition, the filter also to each of the 40 wavelengths. And in the end, you end up here with a fully flexible network. So you could start here from this node, distributing any lambda to any of the other directions, and in the end to any of the other nodes. Some applications for ROADMs. So reconfiguration is a key issue where ROADMs are used. Protection and restoration, it's very important. And of course the control plane is something which is enabling the technology as a whole. So the interworking between the ROADM technology and the control plane, this is something that in the end gets you the complete picture. Some of you might know the Phosphorus project. There's also a booth here in the exhibition area. So ADFA is also one of the partners here in Phosphorus, which has as a design target to create a GMPS control plane also for dynamic light path provisioning. Another advantage of ROADM technology is that it enables you to have a centralized layer-free architecture. So this is also very energy efficient. Actually, you have only one core router in your network, as briefly lined out before. Transport within the network is done in all optical. Here is a more view on the technology, how it would be realized. So this would be again a degree 3 node, 40 lambda, directionless and colorless. So this is a first network interface, second network interface, third network interface. Here we have the H21 WSS module on each of these nodes. We have an optical supervisor channel here, in each of these nodes, plus EDFAs, optical amplifiers. And this here is the local node for the interconnect of the incoming, outgoing traffic at this specific node. And this here, this is the colorless add-on. So this would be the colorless filter. So any traffic which is coming in here can be actually switched to any color and then distributed over the network starting from here in any of the three directions. So this would be then, again, a colorless plus directionless configuration, to give you an example. Here are some of our customer references in the research and education area. There are some NRENs here. So we have Pioneer. There's another slide. Here's the last slide to give you some more details. HEANet, Arnes in Slovenia, and several other customers. We have here the Phosphorus logo, where we are also a partner. And some of you might remember Dragon. This is here on the bottom. This was a pretty early ROADM demonstrator in the US, where Adfar also was participating with the company called Movas, which we acquired 2.5 years ago. So these guys are really pioneers in ROADM technology and also in GMPLS. And this was integrated into our Adfar portfolio over the past year. The last slide I want to show you here is the Pioneer network in Poland from PSNC, national backbone. This is the landscape of Poland here. And they have around 4,000 kilometers of fiber interconnected with Adfar optical networking technology, all 10 gig based, so they currently have 2 10 gig lambdas. And the nice concept also that they laid out here, so they have interconnects to various other countries. See it here at the edge. So this is cross-border dark fiber to various neighbor countries. There's also a booth in the exhibition area of PSNC, so if you would like to have more details, just feel free to go there. Okay, so I'm open for questions, if there are any. Otherwise, feel free to come at our booth. So we are here until tomorrow noon.
Any questions? Yes, thank you. Who is this one? Okay. So, then I can introduce our last speaker, Mr. Jan Hoff of Extreme Networks, and the floor is yours.
Okay, thank you, Karel. Good morning, ladies and gentlemen. My name is My name is Jan Hoff, and I'm responsible for field marketing in Europe, Middle East, and South America. And what I would like to do in this short presentation is to share some trends we see in the data center market today, and maybe at the end have some discussion on it as well. Before I dive into that, I would like to introduce the company to you. Although I'm 100% aware that probably all of you will know Extreme Networks in detail, maybe it's just wise to share some of the details with you. We started the company in 1996. We are focusing on layer 3 switching. We are noted on the exchange, on Wall Street for more than 10 years. We have shipped more than 20 million layer 3 ports. In our model, we work in a strict 2-tier channel model. So we have, say, offices in around 50 countries around the world, and we have more than 600 partners who help us with project implementations at our customers. Quite a large portion of our revenue is flowing back into the market. We spend 18% of our revenue on R&D, and with that, we are holding more than 200 patents, and one of the probably most known patents is about the Ethernet quality of service, which is held by Steve Haddock, one of our founders and CTO of the company at that time. If you look to our revenue, about 30% of our revenue is coming from the service provider market. About 70% of our revenue is coming from the enterprise market. And what we see is that, due to the recession today, we see a decrease in the market for layer 3 switching in the converged enterprise market. But the good news is that we see about an uptake about 10% annually per year, if I may believe the analysts of Gartner and IDC, in the data center market. And we do about 25% of our overall revenue in the data center market. So what we see happening in the data center market is that really cost is driving all the developments in the data center market. So we see the introduction of very powerful multi-core CPUs running on blade servers to increase the density of the number of servers you can use in the data center. And all these servers need to be interconnected with 10 gig to be able to support sufficient data to the applications running on it. And actually what we see is that you see some kind of a cyclic trend in the data center market. And whereas 20 years ago, all the applications were consolidated on the data center. The next 10 to 15 years, we saw desktops coming to the market. We saw laptops becoming available to the market, very powerful machines, and all the intelligence, all the applications were distributed. And right now, we see again that consolidation into the data center. And still, the end user is expecting the same kind of performance, the same kind of experience from the data center, which puts additional requirements to the network. Not only connecting servers with 10 gig, but also making sure that when a client is using an application at the data center, he's getting the same kind of experience with regard to performance, with regard to availability, etc. If you look to 10 gig, I think it's already coming from quite some time ago. And the 10 gig standard was released in 2002. In 2004, respectively 2006, we saw the standard for PCI Plus coming to the market, allowing to use more power over the PCI Plus interface. In 2006, the 10G base T standard was available into the market and became released. And in 2008, we saw quite a lot of products essential to use 10 gig in the data center being released. Intel released their 10 gig NIC cards, and we released our 10 gig fixed switch as well, which can either run 10 gig over fiber, but more importantly, can also run 10 gig over copper using 10G base T, allowing a smooth evolution path of 10 gig into the data center. And in the next step, we can anticipate that we will not have separate NIC cards anymore, but the 10 gig interfaces will be integrated on the motherboards of all the servers as well, again using the Intel technology. A question you could ask yourself, okay, why do we need 10 gig? And why do we need it today? And the reason why we need it today is that those multi-core CPUs need to have more data delivered to the applications running on virtual machines at the servers. Using virtualization allows us to make much better use of all the processing capacity in the server farm. But it's also putting quite a number of requirements to the network as well. Because the network must be able to follow an application when it's moving, when it's floating in a virtual machine over the server farm, to guarantee the quality of service, so that the end user, the client at the end, is ensured with the performance he's expecting from that application as if it was running on his local machine. So that's one requirement we have to put to the network. Another requirement which is quite important and where the NIC plays quite an important role is that the NIC is doing the pre-processing of the 10 gig data stream to make sure that the right data is flowing to the right application on that specific server. And that is where Intel has a very advanced intelligent solution in their NICs as well. If you look to data center configurations, we see more or less two kind of standard configurations being applicable in the data center. One configuration is what we would call an end-of-row configuration, where you have all the switching, all the networking gear consolidated into one rack, and then being connected with cables to the different servers and the different server racks. The advantage is you use less switches. The disadvantage is you have a higher amount of cabling. Another configuration we quite often see is what we would call a top-of-rack configuration, requiring less cable, because in every server rack you put a switch, but requiring some more switches. And it's up to either the person who's in charge what kind of configuration they favor, because from Extreme Networks we can support both. Our switch, which would I like to present to you, delivering and supporting you with an end-of-row configuration, is the Black Diamond 8800 switch, our enterprise core and data center switch. And we released on May the 11th, we released a new set of blades for that switch. So you're using the same chassis, the same power supplies, and you can just upgrade the switch by sliding in a new management module, which will give you 80 gig per slot for the 8-slot chassis, or 128 gig per slot for the 6-slot chassis. And with the use of 24-port 10 gig cards, we can increase the number of 10 gig ports to 194 per chassis, or even up to 582 per rack. And if I take a step back a little bit in time, and I look at the moment when we first introduced 10 gig into the market, that was around 2002, we had only 8 ports of 10 gig in one chassis. That means up to 24 ports of 10 gig in a rack. And right now, you see within 7 years, the density has not only doubled or tripled, it is 20 times more, 20 times higher density. And what is quite important of this, these new blades is that you can reuse the existing chassis. You can even mix and match all the new blades so you can preserve the investments which you have been doing. One key point in the data center, and that's the key point we are addressing as well, is the fact that many data centers are limited with respect to how much power can you bring into the data center and how much heat can you get out of the data center. And for that reason, we took special care that we designed our switches in such a way that they are really low in power consumption. So if you look to the Black Diamond 8800, that switch is consuming about 1/3 of the power some comparable switches of some of the other vendors are using. And not only did we do that, we also created a widget, or a script you could call it, which is allowing us to put unused ports in some kind of a hibernation mode. So that if you have a port which is not used, you reduce the power consumption even further with another 70% to about 30% of the nominal power. And again, that is quite unique. Now the widget we created for using this hibernation is quite a simple one. And in order to explain you a little bit more what we can do on widgets, we have at the end of the trainer conference on 1:30 on Thursday afternoon, we are organizing a workshop explaining you all about widgets and what we can do to automate frequent occurring tasks in the network by the use of scripts. Among the participants of that workshop, we will give away one Summit 250. So you can go home tomorrow with a Summit 250 switch of Extreme where you can test and build those widgets yourself in your own professional environment. And because we believe that this concept is very powerful, so we really want to boost that concept. Besides the end-of-row switch, we also have released in, we are shipping it since December last year, a 24-port fixed switch to support you with the top-of-rack configuration. And that switch did win the Network Computing Award in the UK in 2009 for the best data center product of the year. And the reason why we did win that award is that we brought quite a lot of new innovation, new things to the market. So one thing what we brought to the market is that you can equip this switch with a very high-speed stacking port. So you can build even 2 switches together, and you can create a 48-port non-blocking high-speed switch using a 512 gig stacking cable. We can even stack this switch with gigabit or fast Ethernet switches of Extreme, and still the whole stack is acting as one switch. What we did do as well, we could have gone the easy way where we said we're going to focus to reduce the cost of goods for us by using only one chipset in this switch. Instead, we used 2 chipsets. So to be sure that we can either have a very versatile and flexible interface design to add additional ports, additional capabilities to the switch, but we are able also to support 40 gig and 100 gig uplinks in the coming years in this switch as well. And the last thing which I would like to emphasize, put some emphasis on, is that we are today the first and only switch who can support 10 gig over copper using 10G base T, meaning transporting 10 gig over 100 meters of standard Cat6a or Cat7 cable. If you use Cat6 cable, we can go up to 55 meters. And we believe that the use of 10G base T is a very important, smooth way how you can introduce 10 gig into the data center. Besides 10G base T, we also do support SFP+. So we also have an optical version of this switch available. Compared to XFP, normally the 10 gig optical modules which are used, those SFP Plus modules are way smaller, so you can have a high density 24 ports of 10 gig in only one RU height, but you can also reduce the cost with about 30 to 40%. And the good thing is that with SFP Plus, there is also a passive optical copper cable available, so you can run 10 gig over copper for very short distances as well, for up to 5 to 10 meters. However, we believe that 10 gig is allowing you the smooth evolution from gig to 10 gig, because you simply put a switch in the top of the rack of the server rack, you put in the NIC cards in the server, and you can reuse the same cabling to enable 10 gig in your data center. Like I already said, we have both models available. All these switches, like all our other switches, are using Extreme XOS, our modular operating system. So if you know how to create widgets on a Summit 250, you can reuse these widgets on a Summit 650. You can even reuse those widgets on our high-end, powerful service provider platform as well. What we can do in the back, you can see it here at the bottom picture, we can use what we call versatile interface modules, daughter boards we can slide into the back of the switch, and we have 4 versions of that available. One version is providing you with the standard stacking, so you can stack fast Ethernet gig and 10 gig all in one stack. Another daughter card we have is giving you an additional 8 ports of 10 gig, so suddenly your switch is becoming a 32 port 10 gig switch. And we also have the high-speed stacking interfaces, where we can either put 2 switches together, non-blocking Y speed, or we can use a 256 stack, which is a 2-to-1 oversubscribed, but with that we can stack up to 8 Summit X650 switches all in one stack. Again, providing with a lot of 10 gig with a high-density 10 gig solution. Another thing we did do with launching the Summit 650 as well is bringing a new software release of Extreme XOS to the market, and in that we also have some nice features helping you with deploying 10 gig in the data center. One thing we brought to the market as well, and we will support also, is what we call cut-through switching. So you can have a lower latency switching solution in the data center as well. So instead of waiting on all the bytes of the packet to be received, do the CSC check and then forward the packet again. As soon as the packet enters the switch, you start forwarding bytes to the next hop, next destination where it needs to go to. So we can achieve very low latency, about 2 microseconds of latency for local switching. Another thing what we will do with the Summit 650 as well, that we are able to run virtual routers on the switch. So that means that on one physical hardware, you can run up to 8 logical instances of a switch. So in principle, you have 8 fully separated switches. Not only separated only from the memory space or from the address space, but also fully separated in using different CPU cycles. So that if one virtual router, for whatever reason, got stuck, the other 7 ones still operate independently of that one and still continue to operate. Another interesting feature is what we would call vMotion support, and that allows us to track and to identify how applications in virtual machines are moving over the server farm. So we can see if an application is moving to a different server, we can identify that and we can make sure that a switch is copying the quality of service, the policy of that port to that new port, so that we can ensure that the client being connected using that application is still having the same performance, is still having the same behavior of that application. Now with vMotion, we are not only compatible with VMware, the solutions of VMware, we're also compatible with Hyper-V of Microsoft, and we're also compatible with Zen, the Zen's virtualization software solution of Citrix. So we support all the 3 main virtualization software vendors available or running in the market today. We're also working, because it's very nice, of course, that we bring a new switch to the market, but it's only part of the solution. So we're working very close with Intel to push and to advocate the use of 10G base T in the data center, because they are having the NIC card there, which can do the pre-processing of a 10 gig data stream to make sure that the right data is going to the right application without putting additional load to the CPU. So all the processing power of the CPU remains available for supporting the applications. And like our switches, they also support fiber channel over Ethernet for storage and ISQC as well, like our switches can also support that. I see I have 2 minutes left, so I should be more or less in time then. But I thought I had more time. I think all these people are not hungry at all, so I think I could use another 15 minutes. But okay. So we also tested our solution in the Intel labs in the US. And we also did do some cost calculations on comparing a gig solution of Extreme and Intel versus a 10 gig solution of Extreme and Intel. And we found out some very interesting points. If you look at the total solution, where you say, I'm going to use 10 individual gig ports to provide 10 gig connectivity to the server, or you compare that to one 10 gig to the server, you can see that you can save about 30% in cost, you can save about 40% on power, and you can save a factor 4 in space. So in that sense, I think you're, with 10 gig, addressing the three main issues we see in the data center today, that is about cost, power, and space. And with that, I think, 10 gig, I come to a conclusion of my presentation. 10 gig is available and affordable for today's data center. Copper is definitely the lowest cost option in the data center. It's allowing you a smooth migration path from gig to 10 gig. Because they're doing some solid partnering with vendors like Intel, but also with people like Dell. And if you want to know more about what we can do on 10G base T, please come to our booth. We have a small booth over here, and you can see the real product over there. And with that, I would like to conclude my presentation. Thank you. Any questions, maybe?
Any questions for Mr. Jan Hoff? There's a question over there. Do we have a microphone? Yeah, over there.
Well, just to share my opinion that copper as an option usually is quite limited to a particular set of scenarios. It really stays inside the data center, and if you want to have 10 gig lambdas coming from outside the data center and terminate on SFP plus lasers, that's a very economical way of connecting these kind of devices directly to the WAN. And in that case, copper, as you presented, is not, I don't see it as such attractive technology option. And they are talking about category 6 and category 6A, and I think that means new copper, not the most widely deployed category 5 copper. So I was just wanted to give back to the audience some balanced opinion on my experience regarding copper as a lot better than fiber for 10 gig. But
okay, maybe some comments on that. I think it's all very dependent on what is the kind of configuration you're running in the data center today. If you say already run some kind of a top of rack configuration where your fiber spurs are coming into an end of row switch, and then you go on with copper, you have a smooth evolution path. I also speak with some customers who are using true only fiber in the data center as well, and then of course SFP plus is the solution. But if you say I have a data center where I'm using copper, or I want to build a data center where I'm really concerned about cost, I think copper is a good alternative. Yeah? But you're fully right, it depends a little bit on the configuration you have today as well. Yeah? Fully agreed. Yeah?
Okay, thank you very much. That brings us to the end of our session. There's now a lunch break, so what you can do is go and queue for lunch, but a lot of people will be doing that. So if you're smart, you may do something else first. For example, talk to the presenters either here or at their booth and buy some of the kits that they have been advertising. Or alternatively, you can go to the demonstration area, which is on this side of the exhibition hall, just beyond the registration desk. There will be a demonstration there in 3 minutes' time of surgical teleconference with DVTS, and also 15 minutes before the end of the lunch break, if you're eating a little bit faster and you don't need a full hour and a half to have lunch, then at 2:45 there will be a demonstration there of CNIS, the Common Network Information Service. So enjoy the lunch break and do something useful at the same time. Thank you.